Hi, fourth grade. My name is Holly Whittle, and I'm a fourth grade math teacher at Shannondale Elementary. I'm excited to be here with you today for the KCS at Home Summer Edition. Today's lesson will focus on classifying two-dimensional figures. So when I see that word classify, I know that I'm going to be sorting something, and I'm going to classify these shapes based on certain attributes or certain things that I see within each of those shapes. And when I see two-dimensional, I know that two-dimensional means that that shape only has two dimensions, such as a length and a width. They're those flat shapes that I could draw on my piece of paper. So we'll be seeing those two-dimensional shapes throughout our lesson, and we'll be putting those shapes into categories. So as we look at our learning targets today, what are some of the things that we are going to accomplish? These lessons might be lessons that are new to you. It might be new information, and it may be something that you have learned this year in fourth grade when we were in our buildings. This was toward the end of the curriculum, so it may be new information. So either way, let's get started. So we are going to compare quadrilaterals. When I see the word quadrilaterals, I see that piece quad, and I know quad means four. So I'm going to be comparing four-sided figures and looking at those four-sided figures and seeing what is the same about those and maybe what is different. All right, we are going to sort shapes based on sides. So the vocabulary that we're going to use with this is we are going to look at the sides of the shapes, and we are going to decide if those sides can be classified as parallel and perpendicular. So parallel, if I extended my two sides, my two opposite sides, those sides would never intersect. They would run side by side. They would go on forever in each direction, and they would never intersect because they are the same distance apart at any point. And then we have perpendicular. And when I look at that word perpendicular, I see that for me, to help me to remember this, I see per and I think of perfect. And I want those perfect right angles. If I extended those sides, I would have perfect right angles in each of my corners. We are also going to sort shapes based on angles. So we're going to look at the corners of the shape, and we are going to look at those angles, and we are going to decide, can those angles be identified as right angles? We know right, I like to say just right, because those right angles are going to be measuring exactly 90 degrees. And I could draw a perfect square in the corner. So I like to say those just right angles measure exactly 90 degrees, no more, no less. My acute angles, the way I remember this is that those angles are so cute. They're smaller than 90 degrees. So those angles, the opening in those angles is going to be less than 90 degrees, but greater than 0 degrees. So anywhere from 0 degrees to 90 degrees, if an angle measures that amount, it would be that acute angle. And our last angle that we're going to focus on is the obtuse angle. I say this word a little funny to help my students remember it, but we say obtuse. And the reason we say it like that is because we want to remember that that's a big voice and that that's a big angle, or it's greater than 90 degrees. So my angles that are greater than 90 degrees, but less than 180 degrees, so less than a straight angle, would be classified as an obtuse angle. The last thing that we're going to focus on today, the last skill, would be sorting triangles based on angles and lengths of sides. So we're going to look again at these angles, and then we're going to look at the lengths of the sides to see how those triangles are alike and different. So let's get started with comparing quadrilaterals. And remember, our quadrilaterals are our four-sided figures. We're going to look here at this question. It says, is every square also a rectangle and a rhombus? Use the table to compare. This can be found in your packet, and the first 2 pages of your packet is what will correlate with this slide today. So we have a square, a rectangle, and a rhombus. So we're going to complete this chart together. I'm going to decide if these descriptions match each of these shapes. So when we look at a square, does a square have 4 sides and 4 angles? Well, I see 4 sides. I also see 4 corners or 4 angles in that shape. So yes, that would match that. A square would classify as having 4 sides and 4 angles. 4 square corners. Well, when I see the word corners, I know it has 4 corners, right? Because it has 4 angles. 4 square corners. Well, I see, and when I see square corners, I think if I form a perfect square, that would be 4 90-degree angles, right? Or 4 right angles. I do see 4 square corners. So yes, that would also be classified, a classification for a square. When I look at 2 pairs of parallel sides, well, I see the opposite sides here, the top and the bottom. If I extended those sides, they would go on forever in both directions. So those would be parallel. And then my left and right sides, if I extended those sides, those would also go on forever in each direction. So yes, 2 parallel sides would be a classification for a square. All right, and now 2 pair of sides that are the same length. So I see my left and right side are the same length. I see my top and bottom side are the same length. So those opposite sides are the same length. So yes, and in a square, I have all 4 sides that are the same length. That is how when I see a shape and I see it if it looks like a square, I can measure those 4 sides, and if all 4 sides are the same length, then yeah, that would classify as a square. So when I look at a rectangle, let's look at these classifications, see if they match for rectangle. 4 sides and 4 angles. Just like a square, I see 1, 2, 3, 4 sides because it's a quadrilateral, and I see 4 angles. 4 square corners. Here I do see 4 square corners, so, or 4 right angles. So yes, that would be a classification as well. 2 pairs of parallel sides. I see the top and bottom are parallel. They run side by side, and if I extended them, they would never intersect with one another. And the left and right, the same thing. If I extended those, they would never intersect. So yes, I would agree with the 2 parallel sides. 2 pairs of sides that are the same length. Well, I have a pair here of opposite sides. Are those 2 sides the same length? Yes. And my left and right side, are these 2 sides the same length? Yes. So I have those 2 pairs of sides that are the same length. 4 sides that are the same length. This is where it gets a little tricky. So when I look at a rectangle, the definition of a rectangle tells me that I need to have 4 sides and 4 angles and 2 sets of parallel sides. There's not a specification on the lengths of the sides. Yes, if I saw 4 sides that were the same length, I would define it as a square. But sometimes a rectangle could have those 4 sides that are the same length. Let's look at a rhombus. 4 sides and 4 angles. I see 4 sides, and in this rhombus, I see 4 angles. Now, in this rhombus, are my 4 angles right angles or squares in the corners? No. But the definition of a rhombus doesn't really specify that. So it is possible that you could have those square corners in a rhombus. 2 pairs of parallel sides. I see these, the top and bottom, that would go on forever in both directions. I also see the left and right side that could go on forever in both directions and never intersect. So yes, I would have, oh no, there we go. Those 2 set pairs of parallel sides. Now let's look at 2 pairs of sides that are the same length. I see the left and right side are the same length. I see the top and bottom are the same length. In this, like a square, I see all 4 sides are the same length. So I can check this and this. So when looking at the table that we've completed, I'm now able to say that yes, every square can be named as a rectangle and a rhombus. So every square could also be classified, could be named as a rectangle and a rhombus. Okay, so this table will help you to complete that page 1 and 2 in your packet, or the first 2 pages in your packet. Let's keep going and let's look at sorting shapes based on sides. So we talked about how we're looking at those shapes and looking for parallel sides. So the opposite sides are parallel to one another. They never are going to cross or intersect. And perpendicular sides where they form those perfect right angles where you could draw that square in the corner. So let's look at these shapes. So it says sort the shapes in the box based on parallel and perpendicular sides. Put the shapes in the Venn diagram below. I know that you've used Venn diagrams in ELA often, so this shouldn't be something that's unfamiliar to you, this organizer. So when we look at this organizer, if this shape only has parallel sides, I'm going to place it here on this side of the organizer. If it only has perpendicular sides but no parallel, it's going to go on this side. And if I see both parallel and perpendicular sides, I can put that right here in the middle. Okay, so let's look here at the rhombus. So when I look at this rhombus, if I look at my opposite sides, I see, I'm going to try to highlight here as the opposite sides. So we have this side and this side, and if I could draw straight lines with this, I would hopefully see that those lines would never intersect. Okay, I have my opposite sides that would never intersect, so I do find a pair of parallel sides. I see 2 pair of parallel sides because I also look at my top and my bottom. And if we look back at the chart we just completed, we talked about having those 2 sets of parallel sides. So when I classify my rhombus, I know it's going to fit here in parallel sides, but could it also fit in perpendicular sides? I remember that for perpendicular sides, you must have 4, or you must be able to create a right angle in the corner. I see an acute angle here, and I see an obtuse angle here, acute and obtuse. So no, I don't see any right angles in the rhombus, so therefore I know that there's no perpendicular sides. So I'm going to classify my rhombus into the parallel side category. Let's look at a triangle. I know a triangle only has 3 sides because tri means 3. And when I look here at this triangle, I look first for parallel sides. Are there any opposite sides in a triangle? No, and I see that if I extend these sides, they're going to intersect. So I cannot classify them as parallel. Let's see if we can classify them as perpendicular sides, as having perpendicular sides. Well, here, these lines would intersect, but they wouldn't form perfect right angles. And same with these 2 sides. Let's look here at this corner. If I extended these 2 sides, would I form that perfect right angle? Would I form those perfect right angles? Yes, so I can say that this triangle has perpendicular sides. So I'm going to place it here in this piece of my organizer. All right, let's look at the square. We know from our previous slide that square has 2 sets of parallel sides. These opposite sides are parallel, so I know it'll fit here. And I also know that there are 4 right angles in a square. So if there are right angles in a square, I know that I'm going to have perpendicular sides because those sides are going to intersect exactly at 90 degrees. So I'm going to place my square right here into this middle category that would be defined as having parallel and perpendicular sides. All right, let's look at the hexagon. So when I look at the hexagon, I'm looking at for opposite sides first because I want to see if those sides are parallel. So let's go ahead and look at the top and bottom. If I extended those two sides, would they ever intersect? No. So that tells me that those two sides are parallel. If I look, let's see, here's another, whoop, that one's a bad line. And when I look at these two opposite sides, they would never intersect. And lastly, when I look at these two opposite sides, they would never intersect. So this hexagon actually has 3 sets of parallel sides. Now, does a hexagon have any perpendicular sides? Remember I said to have perpendicular sides, you must have right angles. Do we have any right angles in that hexagon? I see all obtuse angles because these angles, if I measured them, would all measure greater than 90 degrees. So I'm going to put the hexagon in the parallel sides only. Okay, and let's look at the rectangle, this last shape. And let's look first at the opposite sides. I do know that from the previous slide that a rectangle has 2 sets of parallel sides, so it definitely fits here. Let's look at the corners. I see that I have 4 right angles. So when I have 4 right angles, I know that I'm going to have perpendicular sides because those sides are going to intersect exactly at 90 degrees. So I can place my rectangle into that center category of parallel and perpendicular sides. Okay, so pages 3 and 4 in the in your packet, so the 3rd and 4th page, you will see this example, but then the example will also help you with completing that piece of the packet. Also included on page 3 and 4 will be sorting shapes based on angles. So we're going to look at the angles that we see within shapes and we're going to sort them. We're going to do a little activity here with the Venn diagram again. This Venn diagram looks a little bit different from the first Venn diagram that we focused on. On the first Venn diagram, we had 2 categories. For sorting shapes based on angles, I know that we're looking at right, acute, and obtuse angles. So I have 3 categories I'm looking for. So when I look at, I can use a triple Venn diagram or a Venn diagram that has 3 categories to sort these shapes. So if a shape only has acute angles, we would put that shape into this category of acute angles over here. If it has only obtuse angles, it's going to fit down here. And if it has only right angles, we would place that into the category of having only right angles. Now, if a shape has acute and obtuse, would fit into this category. Right and obtuse would fit into this category. Right and acute would fit into this category. And then what would that middle category, what would be included in that middle category? I see that all 3 circles intersect and have a space of in this middle of our Venn diagram. So that tells me that a shape must include acute, right, and obtuse angles to fit into that category. All right, let's get started. So let's look at this triangle first. And when I look at this triangle, I see 3 angles. And if I were to measure those angles, I know that all 3 of those angles would measure less than 90 degrees. And I call that acute. So I know that this has 3 acute angles. So I'm going to place this here into the only acute angles category. Okay, let's look at this shape. It's a triangle also. So can I automatically assume that it has 3 acute angles? No, because triangles can look different. Yes, a triangle has 3 sides and 3 angles, but triangles can look, there are many types of triangles that we are going to classify, and we're going to do that in the next part of our lesson. But let's look at this triangle. I see an acute angle here, smaller than 90 degrees, and I see an acute angle here, smaller than 90 degrees. So I know it includes acute angles. What do we see right here? I see a perfect right angle. So if I see that perfect, just right angle, that's going to be classified as having a right angle. So I have right and acute. So here's my right angle category. Here's my acute angle category. So I'm going to stick this triangle right in the middle of those two. All right, let's look here at this rhombus. When I look at this rhombus, I see 4 angles. 2 of those angles are acute, and 2 of those angles are obtuse. They're going to measure greater than our just right angles. So let's place this between acute and obtuse because it's going to have both acute and obtuse angles. All right, let's look at the square. Square, I see 4 angles. All of those 4 angles look exactly the same. And I see that they're all, I can draw perfect squares in each of those corners, which tells me that there are 4 perfect right angles. So I'm going to place this square into my category of right angles only. Okay? Let's look at the hexagon. When I look at the hexagon, I see 1, 2, 3, 4, 5, 6 angles because the hexagon has 6 sides and 6 angles. So when I look at those angles, they look like they're greater than 90 degrees. If I were to put them next to this square, I'm not gonna be able to do that, but if I were to try to draw a right angle, I could not do that. So I know that they're going to be greater than 90 degrees or obtuse angles. So, and only obtuse angles. So I'm going to put that down there in the obtuse angle category. Okay. Let's look here at the pentagon. I have 1, 2, 3, 4, 5 sides. And I have 1, 2, 3, 4, 5 angles. And when I look at these angles, I see some right angles down here in the corner. That's like the bottom of a square, right? It's like if I were to compare it to this, that looks the same. But then I see the top is a little bit different. When I look at this angle, I see that that's going to measure greater than 90 degrees. So these angles up here are measuring greater than 90 degrees or obtuse. So I'm going to place this into right angles and obtuse angles. Okay, lastly, let's look at this shape. Well, I see this side of it. If I were to cut this off, it would be like a rectangle, but I have this extra piece. So I see a right angle here and a right angle here. So I see 2 right angles. And then I see here an angle that is greater than 90 degrees or an obtuse angle. And then in this corner, I see an angle that is less than 90 degrees or an acute angle. So this shape has all 3 types of angles included in that shape. So that shape would go into my center category of having acute, right, and obtuse angles. So sorting these shapes in the previous slide on sorting shapes based on sides, you should be able to complete the 3rd and 4th page in your packet this week. All right, let's go ahead and move on to sorting triangles. We're going to sort triangles first based on the angles within our triangles. So when I look at triangles, I know that triangles have 3 angles and 3 sides. And when I look at the angles in the triangle, I see a right angle here. And so I do see the name of this triangle is a right triangle. So the definition of a right triangle is that one angle is a right angle. So it just has to have one right angle in order for it to be classified as a right triangle, okay? Now for an acute triangle, it's gonna look a little different. I see an acute angle here, I see an acute angle here, and I see an acute angle here. So, I think maybe for it to be classified as an acute triangle, all the angles must be acute. For right, I just had to have one right angle. But for an acute triangle, all three angles are acute. Now let's look at the obtuse triangle. What makes an obtuse triangle named an obtuse triangle? Well, I see an acute angle here, and I see an acute angle here, but this angle is obtuse. So like a right triangle, for an obtuse triangle, only one angle is an obtuse angle, okay? So if one angle is obtuse, it's called an obtuse triangle. If one angle is right, it's called a right triangle. But if all three angles are acute, we name it an acute triangle, okay? All right, so that's sorting our triangles based on angles, but we're also going to sort triangles based on the lengths of the sides. So these are kind of fancy math names that you may not have heard. We've heard of right, acute, and obtuse. These names are probably going to be new to you, okay? So let's look here at the lengths of the sides. And we're looking at the sides, and these little tick marks here on my triangles just tell me that if they have the same tick mark, like 1, that means that those sides are the same length. Here, I see 2 of those sides are the same length, but there's 1 that's different, okay? And here, I see that all 3 of these sides are different because I see 1, 2, 3 little marks on it. So let's look here. This is called an equilateral triangle. This is pretty easy to remember because I see I hear that word equal in equilateral. So when I hear equal and equilateral, I think all 3 sides are equal lengths or are the same length. So if I measured using a ruler, all 3 of those sides would measure the same length. The next triangle we're going to look at is isosceles. We say it like that, isosceles. And then isosceles triangle, if you can look at the picture, you can kind of see that 2 of the sides are the same length, but one side is different. So the definition of an isosceles triangle would have 2 sides that are the same length. And lastly, let's look at scalene triangle. Say scalene. All right, so a scalene triangle, when I look at it, I see 1, 2, 3 sides, of course, because it's a triangle, but none of those sides are the same length. They all have different lengths. So the definition of a scalene triangle would be no sides are the same length. Okay, so let's practice sorting triangles based on angles and on the lengths of the sides. We're going to use a different organizer for this. We've used a Venn diagram for the last 2. Let's look at this organizer. So we're going to take these triangles and we're going to place them onto this organizer. We're going to classify, like I'm going to look at this green triangle and I'm going to classify it based on the sides. And I'm going to classify it based on its angles. And so I'm going to place it where it would fit on this chart. So let's go ahead and try one. Let's look at that green triangle. I see that this green triangle, it looks to have 2 sides that are the same length and 1 side that is different. Oh, I remember that's called isosceles. If it has 2 sides that are the same length. But I need to know, do I place it here, here, or here? So I am going to decide, is this triangle a right triangle, an acute triangle, or an obtuse triangle? Well, when I think back to what I learned about those 3 types of angles, it must include a right angle to be a right triangle. I don't see a right angle in that triangle. it must include an obtuse angle to be an obtuse triangle. I don't see an obtuse angle, but I do see 3 acute angles. So I would classify that triangle as isosceles and acute. All right, so that's where we fit in this organizer. Let's look at this one. Well, it looks to me like, and I don't have my ruler, so if you were measuring on your paper, you could use your ruler to make sure those sides are the exact same length. But I think it looks to me like this side here on the left and this side on the bottom are the same length. But this side is way longer. So I do think that this is gonna fit into isosceles as well. But I look at those angles, I see an acute angle and I see an acute angle, but do I see all 3 acute angles? No, right here, I see an obtuse angle. So an obtuse angle, if it has only one, that means it's gonna be classified as an obtuse triangle. So let's keep going. So right now, all of ours have been isosceles so far. Let's look at this one. Ooh, when I see these 3 sides, to me, those look to all be the same length. This is the triangle that you probably first were introduced to when you were introduced to shapes. This is that common equilateral triangle. The reason it's really pleasing to the eye because it has those equal sides and in the same measurement for the angles. So when we see that, it's kind of like that's our main triangle that we see when we first start introducing shapes. So I see equal sides, and then I also see 3 angles that are all acute, that are all smaller than 90 degrees. So I'm going to put this into equilateral and acute because equal, equilateral, equal size, equal lengths for the sides. Okay, let's look here at our next triangle. I see 2 sides that look to be the same length and one that seems to be a little bit longer. 2 sides the same length. I remember we call that isosceles. And then I'm gonna look at those angles. I see an acute angle here and an acute angle here. If I put it into a corner, I can see if there's a right angle. I do see a just right angle. So I would classify that as isosceles and right. Okay. Let's keep going. We need some scalene triangles over here, don't we? All right, let's look at this one. Remember, scalene means no equal sides. Do you see any sides that are the same length here? I see the shortest side here, and then the bottom, and then this longer side that connects that diagonal. So I'm going to place this in scalene, and then I'm going to look at my angles. I see an acute little angle in that corner. I see an acute angle at the top, but right here, oh, I see a just right angle. So I'm going to classify that as scalene and right, a scalene and right triangle. All right, let's look at this one. Okay, so I see the length of this side is definitely shorter than the other 2 lengths. And then this side is a little bit longer, and then the longest would be this side on the bottom. So I think that there are no equal sides here. So when I have no equal lengths, it's going to fit into the scaling category. And then when I look at the angles, I see acute here and I see acute here, but this one I see is bigger than 90 degrees. So I would classify that as obtuse. So when I place that into my obtuse category, it would be scalene and obtuse. Okay, so the last one we're going to classify is, it looks to me like it has, these 2 sides are pretty close, but I don't think they're the same length because I have this little bit of a diagonal here on this, on the top. So I think that this triangle could be classified as scaling because there are no equal sides. These are close, but they're not the same length. So I'm going to place that into scaling. And when I look at the angles in this triangle, I see 1, 2, 3 acute angles. And remember, to be classified as an acute triangle, you must have all 3 acute angles. So I'm going to place that here into scaling and acute. Now I have 2 empty spots on my triangle. On my organizer. Equilateral right and equilateral obtuse. Well, when we look at our right angles, or our right triangles and our obtuse triangles, I noticed something. I noticed that if you have a right angle or if you have an obtuse angle, you're going to have this diagonal that connects the 2 sides, and it's always going to be longer. So I know that it's not possible to have an equilateral right triangle or an equilateral obtuse triangle. The only equilateral triangle is going to be an acute triangle, to have those 3 sides that are exactly the same length. So these 2 spaces are blank for a reason, because that is not a possibility to have that equilateral right triangle or equilateral obtuse triangle. All right, so the last 2 pages in your packet, the 5th and 6th page in your packet, you should be able to use this chart and the last slide to help you define those triangles and sort those triangles based on angles and on the lengths of the sides. Okay, I enjoyed working with you today. I hope that we learned a lot of information about classifying those 2-dimensional figures, and I hope you enjoy the rest of your summer. Thanks.